All right, it's go time. Hello, everyone. How are we doing on this fine day? As per usual, I'm going to talk a little bit. I'm gonna yap a little bit while I wait for people to trickle in, and then we'll get into the lecture. Today, we're talking about hypothesis testing, which is the whole reason why you have to learn about statistics when you get a degree in psychology or something like that. The reason that you have to learn statistics, and I didn't know this when I chose to major in psychology initially, was that statistics, of course, well, psychology is a science, and to do science, to do research, we have to use statistics for reasons that we'll get into at some point in this series of lectures. Yes, uh, I'm hoping that this is informative. We're just starting really, really basic today because there's a lot of different types of statistical tests that you can use to test hypotheses, and we're not quite at that point yet. So today, the whole point is just kind of go over the general logic. Huh? So this is the last lecture that I'm going to be doing for a little bit. I do plan to go through this and complete the class that I had planned out for all y'all, but I think I've mentioned this on previous streams. Oh my gosh, this semester has been a lot. My workload unexpectedly got a lot heavier than I had initially anticipated it to be. And it's not really feasible for me to continue these lectures during the semester and maintain my sanity. Academia is like that sometimes. It's very important that we maintain at least some modicum of sanity throughout our teaching, or else our poor students will suffer for it. So, that's what we're last lecture for a while today. I'm not sure when I'll be back. I might come back, say, in December when my other job's teaching comes to a close and I have a little more time and energy to prepare proper slides for all y'all and all that. But for now, we're going on break after this. Though, when I come back from break, we'll get started on t-tests, which are a particular type of statistical test that you might actually encounter if you were to read an empirical article, some sort of article in psychology. It's a test that's really great for testing the control group versus the treatment group. I hope that all of your semesters are going well and are a little less wild than mine. I'm doing my very best to keep my head above water, but let me tell you, things are a little wacky. You know, I feel like that's a thing that we don't talk about a lot as college educators. Midterms and finals season is absolutely terrifying for students, but it is also very, very terrifying for the people teaching the class. Speaking of, I actually have to write an exam soon. I have to write a statistics exam soon. Don't worry, it's not for you. I can write y'all a statistics exam at some point if you'd like. It wouldn't be for any credit or for any grade, but, just for practice. But I have to write one for my job at my other university soon, and writing exams is not my passion. I'll do my best, though, for the sake of my students. We do what we can. Mm-hmm. All right, I think that's probably enough stalling for now. Now, let's get into the lecture. Let's start talking about hypothesis testing. Let me pop over here. We are at the slides. We are at the slides. Okay. So, hypothesis testing. So far, up until this point, all the lectures that I've given you so far have been about types of descriptive statistics. If you remember from the very, very first lecture, descriptive statistics are statistics that are trying to summarize and organize data. They're trying to take a whole bunch of information and condense it into a few numbers. We talked about measures of central tendency, so the mean, the median, and the mode, which all aim to describe the typical value in a set of scores. And we talked about measures of spread, like the variance and the standard deviation, which aim to measure how closely clumped together or how spread apart are your scores. And finally, we talked about z-scores, which their whole goal is to describe how typical or atypical a score is, or the way that it does that is by saying how close is this score to the mean, or how far away is the score from the mean. In other words, how extreme is this score? we're gonna get started by talking about inferential statistics today. Inferential statistics is pretty much all of the statistics that you see, well, most of the statistics that you see in published research papers. This is the stuff that people use to test hypotheses. If descriptive statistics are just summarizing data, this is trying to get new information out of data. These are used for hypothesis testing, for comparing samples to populations, and for comparing samples to other samples. So control versus treatment group, I think, is sort of the classic example. So of course, this is a psychology and anime channel, so here's the example we're working with today. Hello, welcome to the lecture. Feel free to drop in with any questions you might have at any point. So, for this case, let's say I want to know if shonen manga, you know, like, well, Demon Slayer's the one in the picture, or Naruto, or One Piece, or what have you, if they, on average, are longer than manga in general, if shonen manga are unusually long. So I might be asking myself, are the length of shonen manga and general manga the same, or are they different? Oh, there we go. Well, that's something I can ask with hypothesis testing. What I'm doing, essentially, is I'm going to try and use statistics to say, is it possible that these two groups are about equal length? Or is it that one of these is on average longer than the other? In other words, is shonen manga unusually short, or is it unusually long compared to other manga? So what we're going to do here is we are going to start simple. We're going to compare the population, which is all manga that's ever been published, to a sample where we change something. Or in this case, we're going to compare the population of all manga to just shonen manga specifically. Our sample, of course, is already going to be different from the population. We talked about this a bit before, but when you take a small chunk of a total population, let's say I take 5 people out of a total population of 5 million people, that sample is never going to perfectly represent the entire population. A small collection of shonen manga is never going to perfectly represent all manga or even all shonen manga. So we have to figure out if the length of shonen manga is different from all manga after we account for sampling error. We already know that whatever sample of shonen manga we have will be different from the population of all manga because it's not the population. So we want to make sure that the only difference between the two is the genre. We want to make sure that it's not just the fact that we have a sample versus a population. We want to make sure that the difference in length is actually real. That's the goal. Now, the way that we think about this, in statistics is, if the probability of getting our sample mean is very small, after we account for the fact that samples are different from population, so after account for sampling error, then the sample probably really is different from the population. So let's say, for example, if the average shonen manga is about 25 volumes long, and the average manga in general is an average of only about 14 volumes long, it seems very unlikely that shonen manga are equal length to regular manga. At that case, because there's such a big difference, I might conclude shonen manga are indeed longer than other manga. But let's say that difference is pretty small. If the probability of getting our sample mean, in this case the number of volumes for shonen manga, is very big, so it's pretty typical of manga in general, then we might conclude there's no difference. So let's say I find the average number of volumes of the shonen manga in my sample is only 15 volumes, whereas manga in general it's only 14 volumes. That feels like it's probably within the margin of error. That's within sampling error. We can't conclude that shonen manga is any longer than regular manga in general, or other manga in general. So let's say I have data on the average length of a serialized manga series. I do not actually have this data. I am completely making this stuff up. Please do not cite these numbers. But let's imagine that we do have this data. Let's say the average manga series, the average serialized manga series in something like Shonen Jump or whatever it is, has about 14 volumes. It's about 14 volumes long with a standard deviation of 3 volumes. So 14 volumes on average, give or take 3. So the distribution of all the manga might look like this. We can see the mean is at 14, so on average, manga are 14 volumes long. The standard deviation is 3, so most manga are between 11 volumes and 17 volumes, and very few manga are less than 7, and very few are greater than 21. Again, I do not have the actual data on this. I'm making up these numbers. Yeah, do not trust me on the numbers. I am using them to illustrate a point. The numbers themselves are not... Nah, you're good. I try and be very honest when I'm making up data to illustrate things. So, here's what manga in general look like. We might start to think that maybe a genre, for example shonen manga, might be longer than average if it's very unusual in the total population of manga. If the average number of volumes in a shonen series is, say, more than 20, it's more than 2 standard deviations above the mean, it would be very unlikely that we would have just selected, say, 5 shonen manga that were that long by chance from the population, if there wasn't a real difference between how long shonen manga are compared to the rest of manga. So let's say we want to know shonen manga is longer than other manga, and we might have this hypothesis, maybe we're too intimidated by the reputation of One Piece, but we might have this hypothesis that shonen manga should, on average, be longer, they should have more volumes than other manga. Which means our key question is, does the target demographic, or I'm going to use genre for short, though shonen is really more about the people who are supposed to be expected to be reading this than, the actual contents, but does the target demographic, does the genre predict the length of a series? In other words, are shonen manga longer than other manga? Is this difference real? So our approach might be, we want to compare the number of volumes of a shonen manga to the number of volumes in the average manga overall. And I'm sorry if you hear my cat. He likes statistics, he's very eager to help. He doesn't know anything about it though, so don't trust him if you do hear him. Anyway, let's say the sample mean volume number of shonen manga is a lot different from the population mean. The average shonen manga has like 50 volumes, and the average manga in general only has 20. Well, at that point we could probably conclude there's a difference, but how big does that difference have to be before we start to conclude that shonen manga really is longer on average? Like, if it's a difference of only 1 volume or half a volume on average between shonen manga and other manga, is that really enough to say shonen manga is longer on average? Or could that just be sampling error? Could it just be the fact that samples will always differ from populations? So we need to draw a line somewhere. We need to draw a line where we say, if the difference between manga on average and shonen manga is this big or more, then shonen manga probably is longer than other manga. If it's less than this, if the difference is less than this, then we can't conclude that shonen manga is any different. It could just be sampling error. It could just be we happen to randomly pick some particularly long shonen manga. So again, we have the population of manga. All manga in general has an average of 14 volumes, hypothetically, for this example. And let's say our sample of shonen manga has an average of 20 volumes. There's 2 explanations for why the population mean of 14 and the mean of our sample, our shonen manga, is 20. There's multiple explanations for why these 2 numbers are different. Ooh, the word if is really important in any... Yes. Yeah, in this case, I mean, it becomes subjective after a point, because we are going to have to draw a subjective line. we are going to have to say an arbitrary cutoff of it has to be this different. But yeah, the whole reason we do statistics in the first place is because we want to be pretty sure that any differences we find aren't just a fluke. They're not just sampling error. We want to be pretty sure that it's real. So, yeah, if is very important, and the cutoff you use is very important. And at the end of the day, it's not going to be we're going to try and stay as objective as possible, but we do have to set a cutoff somewhere, and human error and bias can go into setting that cutoff. But research and scientists and statisticians have set kind of like a standardized cutoff, so maybe that helps the bias a little bit when everybody's using the same cutoff. Who knows? Anyway, there's 2 reasons why the shonen manga in our sample might be on average longer than the manga in the general population. The first possibility is that maybe the genre, maybe the target audience has no effect on how long a manga is. And we just happen to randomly select 5 shonen manga that are really long, and we just happen to get a big difference, like 4 shonen manga being 4 volumes longer than general manga by coincidence. There's only a 2% chance, given the population, that this would have been a coincidence, but 2% chance is still a chance, right? So it's possible. The other possibility is that the reason that we found that shonen manga were on average 4 volumes longer than other manga is because there is a difference, that shonen manga are, in fact, on average longer. So the possibility one, that those two means are different, is just, it was a fluke, it doesn't mean anything. Possibility two is that, hey, it actually does mean something. In this case, because there's only a 2% chance that this was a fluke, there's only a 2% chance that we would have randomly seen a difference that big by coincidence, we conclude that it's more likely that the difference is real here. 2% seems pretty unlikely to us. We say it's more likely that shonen manga actually are longer than regular manga than that this was a coincidence. That's the kind of logic that we use in statistics. We say, it seems more likely that something's happening here than that it's not. So at that point, we might conclude shonen manga have a different length than other manga. Our sample manga, the shonen ones, were longer than the general population of all manga in general. That's the logic that this type of statistics operates on. It's more likely that something's happening here than nothing. So, first things first, there's 6 general steps of hypothesis testing. We kind of glossed over them just now, but we're going to break them down now that we've got sort of a general idea of what's going on. And the first step is stating your hypothesis. You can't test a hypothesis if you don't have one. So what we're doing is we're trying to draw conclusions about populations. I may only have like a sample of, say, 5 shonen manga, but I'm trying to draw a conclusion about all shonen manga ever published compared to all other manga ever published. So I have 2 populations, essentially, shonen manga and not shonen manga, and that leads me to 2 hypotheses. Whenever you run a research study, you have at least 2 hypotheses. The first is the one that you think of when I say hypothesis, and that's the research hypothesis. And this is that something is happening here. The mean of population 1 is not the same as the mean of population 2, or in the context of this particular example, the mean number of volumes in shonen manga is different from the mean number of volumes in other manga. The null hypothesis goes along with your research hypothesis, and the null hypothesis says nothing's happening. There's no difference between these 2 groups. Does the probability of these random manga being popular affect the probability of shonen being longer manga? Yes! Yes, it does. In this particular example, shonen manga, and generally popular manga, there's a lot of pressure for them to keep publishing and not end the story. So the more popular a manga is, the longer it tends to be. We're not seeing this trend as much in recent years, but like, if you think of Bleach, Naruto, and One Piece, those were some of those most popular manga and anime in the world, and they went on forever. So that is another variable that is probably going on that might be affecting things here. And yeah, consequently, like, if a manga isn't popular, it's more likely to get canceled with, earlier on, so it won't have as many volumes. So yeah, that is absolutely a variable that might be in play here. We're not going to account for it quite yet. We'll learn how to do that later in the series of lectures, but for now, we're just going to say, yeah, unfortunately, we're just going to chalk that up to being a part of error. But yeah, that could be one of the explanations for why. Yeah. It's interesting. There's a lot of variables in here. No, that's a great observation. Mm-hmm. Anyway, so our research hypothesis is that something's happening. There is a difference. Our null hypothesis is that nothing's happening. There is no difference. So that's step 1, just stating those 2 things. Step 2, we have to determine the characteristics of the comparison distribution, which is just a fancy way of saying describe your control group. What does the typical value that isn't the certain group you're looking at, what do they look like? So in this case, our control group, we're trying to determine if shonen manga is particularly long. So our control group, or what passes for our control group, is any manga that isn't shonen. So that means what this says is we need to describe, on average, how long is manga that isn't shonen. So our comparison distribution is composed of the mean of our control group, in this case, the average length of all shonen, or of all non-shonen manga, which for the sake of this example, is 14 volumes, and the variability around that. So it's average of 14 volumes with a standard deviation of 3. So 14 volumes, give or take 3 volumes. That's our comparison distribution. That's what the average of all other manga that isn't shonen looks like. Then step 3. This is where we say how big of a difference is big enough for us to conclude something real is happening. So step 3, set your cutoff. In other words, how different does your sample, in this case shonen manga, have to be from our population, other manga, to conclude that it is unlikely that we would have gotten that shonen manga mean by chance. That it is unlikely that we found this as a fluke. In psychology, and a lot of other sciences, but like I'm a psychology-focused channel, so we're gonna go with psychology. In psychology, our cutoff is about 5%. We want a less than 5% chance that we would have found the results we did as a fluke, as a coincidence. So this actually, we split up that 5%, we put half of it below the mean and half above, which allows for which allows for me to find that shonen manga is either longer or shorter on average. And this corresponds to a z-score of about plus or minus 1.96. So if our sample mean, if shonen manga's average length is more than 1.96 standard deviations above or below the population mean, at that point we conclude it would be very unlikely to get a sample of shonen manga that long or that short just by coincidence. It's more likely that shonen manga actually is longer. We call this alpha of 0.05. Our cutoff is 5%, alpha of 0.05. If our cutoff was 1%, it would be alpha of 0.01. If our cutoff was 0.01 or 0.1%, our cutoff would be 0.001. But alpha 0.05 is the standard in psychology and a lot of other sciences. So if you ever hear the phrase p is less than 0.05 or p is greater than 0.05, that shows up a lot in statistics memes and stuff. It's referring to this, the probability that you would have gotten the results that you did if the null is true. That's an oversimplification, but yeah. So what this looks like, let's say this is the distribution of all the manga volume lengths. 0, this is the average, so that's a z-score of 0. This would be, in this case of the example, 14 volumes long. The shorter you get, the more unusual that is. The longer you get, the more unusual that is. Our cutoff of 5%, or alpha 0.05, looks like this. If a manga is longer than this, or shorter than this, we conclude that that manga probably is unusually short or long. Or if this genre falls in this range or this range, relative to the general population of all manga, we conclude that it's probably unusually short or long. And you can use different cutoffs, so it shows this is the cutoff that's standard in psychology, 0.05, but sometimes we use 0.01, sometimes we use 0.001, and some other areas of research might default to these other ones as well. But typically, if our sample mean is this far away from the population mean, we conclude something's going on, we reject the null. If it's closer to the population mean than this, then we conclude that it's too likely that this happened by chance. We can't conclude anything special is happening here. So that's step 3. We set our cutoff. How different does our sample need to be from the population to reject the null? Step 4. Now we actually have to figure out how different our sample is from the population. So this is just setting our cutoff. This is where we figure out if we are past that cutoff. And for now, we're going to do that with z-scores. So we talked about z-scores last lecture, but it's just a measure of how far away a score or a sample is from the population mean. So in this case, the population mean, the average number of volumes in a manga series was 14, and the standard deviation of our population was 3, so 14 give or take 3 volumes. Let's say shonen manga is on average 20 volumes long. So let's start plugging that into the formula. Remember, x is whatever score you're looking at, so in this case, x is 20. X is the number of volumes in our sample of shonen manga. Minus the population mean, so how far above the population mean is our sample mean, so 20 minus 14 divided by the standard deviation. We're converting it into units of standard deviation. 20 minus 14 is 6 divided by 3. Our z-score is 2. What does that mean? It means that shonen manga's length was a full 2 standard deviations above normal manga's length, which is pretty far above. That would be pretty unusual. So now we compare the z-score that we found to the cutoff that we set before. So we take this 2 the z-score of 2, and we compare it to the cutoff that we have here of plus or minus 1.96, based on that alpha 0.05 thing. If our sample z-score of 2 is beyond that cutoff of plus or minus 1.96, so if it's further from 0 than that cutoff, if it's further into the tails, we reject the null hypothesis. We conclude that our sample is different from the population. If it's closer to 0 than our cutoff, we fail to reject the null hypothesis and conclude that our sample isn't different. Rejecting I think I actually have a Drake rejection meme in this PowerPoint. It's not necessarily about rejecting the null, but yes, I literally do at the end of this PowerPoint. Not about rejecting the null, but about something related. Yeah. Okay, so that's step 5. You determine whether to reject or fail to reject the null. And then step 6, this is the most important step as far as I'm concerned. Numbers mean nothing on their own. You need to interpret your results. What does it mean that you conclude there was a difference? What does it mean that you rejected the null? So if we reject our null hypothesis, that means our sample was probably statistically, it was probably different from our population. The shonen manga probably is longer than manga in general. And we express this as p is less than 0.05. P here standing for probability, specifically the probability that we would have gotten the sample mean that we did if the null hypothesis was true. Now, why is the probability, or why is P less than 0.05 when we reject the null? It's because if we randomly selected a sample from the population in a world where the null is true, there's less than a 5% chance we would have found a difference as big as we did. So the probability that, so to really oversimplify this, the probability that our results are a fluke is less than 5%. The probability that we just got these numbers by coincidence is less than 5%. If we fail to reject the null hypothesis, that means our sample's too similar to the population for us to conclude it was anything but a fluke, that it was anything but sampling error. At that case, we can't really conclude it's the same as our population, but we don't have enough evidence to say it's different. And in this case, we might express that as p is greater than 0.05. The probability that we would have gotten a sample that was this different from the population by coincidence, by random chance, even if there's no real difference in length between shonen manga and other manga, is more than 5%. And at that point, we're not past the cutoff. This isn't a big enough difference for us to conclude that this was anything but sampling error. We fail to reject the null. So when people say p is less than 0.05, they're rejecting the null. They're saying there is something happening here. If they see p is greater than 0.05, they're failing to reject the null. They say, we don't have enough evidence to say anything's happening here. When I teach this class to other students, sometimes I'll get a student asking me what happens if p is exactly 0.05? And that might sound like a silly question, but I've actually had this happen to me in my own research multiple times. When p is exactly 0.05, technically you should not reject the null because it's not beyond your cutoff. It's sitting exactly at your cutoff. So if p is equal to 0.05, technically you shouldn't reject the null. But you'll see different researchers doing different things with that. But technically speaking, if you want to be technically correct and not make statisticians mad at you, it must be less than 0.05 to reject the null, not less than or equal to. You hit the bull, I guess so. It's just wild to me that that's happened multiple times to me, exactly on point. Like, you hear a lot of p is 0.051 or p is 0.049. No, exactly on the 0.05. No further decimal places. It might be a curse, I don't know. But either way, technically you should not reject the null at that point. The calculation purports p is 0.05, which at least 0.05. Surely. Yeah, the cutoff of 0.05 is arbitrary. I mentioned that earlier, but like, there's no reason it has to be 0.05. In my own research, sometimes I've used 0.01 or 0.001. P-value 0.05000 is true curse. Yes, and I've had that happen to me literally multiple times. I use a statistical software that reports p-values in scientific notation if they're small enough. So if it says 0.05, it is exactly 0.05. But yeah, yeah. You reject the null, p is less than 0.05, fail to reject the null, p is greater than 0.05 or equal to 0.05. So, here's another example. Let's say we've got a research team that's interested in testing the theory that happiness comes from positive experiences. If good things happen to you in your life, you will be happier. And we might sort of narrow this down a bit to say, if people have something very lucky happen to them, will they still be happy 6 months down the line? So we want to see if this effect has some staying power. You're not just happy in the moment, you're happier later too. Let's say we as researchers, I don't know where we got this funding, I don't know who's paying us to do this, but let's say we randomly select one person in North America and give her $10 million. 6 months later, we measure her happiness. Or numbers really like you, maybe. Let's say on this measure of happiness, the population mean is 70, maybe it's out of 100, with a standard deviation of 10, and it's normally distributed. Half of people are below 70, half of people are above 70, most people are close to 70. Call up Mr. Beast to fund this. Please, Mr. Beast, help me with this. Oh, that sounds like a legal nightmare, to be honest, and I don't think you could run a study like this. I don't think the IRB would let you. I don't know if the ethics board would actually let me do this. Anyway, step 1, we've got to establish who's our control group, who's our treatment group. Population 1, our treatment group, the people that we're really interested in, is people who experience extremely fortunate life events, or in this specific study, the person who got $10 million. Please no. Population 2 would be people in our control group, people who did not experience extremely fortunate life events, people that we didn't give $10 million. So we're comparing somebody who got $10 million to everybody else who didn't. So, our research hypothesis. Our research hypothesis is that there is a difference. So in this specific case, this would predict that there is a difference in happiness levels between people who experience positive life events and those who didn't. Or like in more specific terms for this study, the woman who got $10 million should be happier 6 months down the line than people who didn't. Oh my gosh, if Mr. Beast suddenly popped in this stream, I might just panic and hit the end stream button. I'm not gonna lie. I'm not mentally prepared for that. Alright, so in this case, the mean of population 1 is not the same as mean of population 2. People who got the $10 million will be happier 6 months down the line than those who didn't. Or maybe this is a non-directional hypothesis, so maybe they'll be less happy 6 months down the line. You do hear a lot of stories about people who won the lottery getting like really stressed out. A bunch of people in their life are suddenly asking them for money. They've got a lot of taxes. But either way, our research hypothesis is that giving this woman $10 million will do something to her happiness, even 6 months down the line. The null hypothesis, which is just sort of you can call it the devil's advocate, is that there's no difference. Giving somebody $10 million might make them happy in the moment, but 6 months down the line, she should be no more or less happy than the general population. So research, there is a difference. Null, there is no difference. Null, no. Null, none. So that's step 1. We've stated our hypotheses. Step 2, we have to determine the characteristics of the comparison distribution, which again is just a fancy way of saying, what does our control group look like? What's our population look like? In this case, for happiness, we know the population has an average of 70 on this happiness scale with a standard deviation of 10. Most people are scoring at around a 70, give or take 10 points. So that's step 2. We've described what happiness looks like in people who didn't experience this extremely fortunate life event. Step 3, we set our cutoff. How different does our sample need to be from the population for us to reject the null, for us to say that there was a difference in happiness? In this case, we're going to use that standard cutoff of p is less than 0.05, which corresponds to a z-score of plus or minus 1.96. This is just sort of the standard in psychology. It's going to stay this way as long as we're working with z-scores. It'll change a little bit once we get into t-tests and things like that. But for now, this is our cutoff. Step 3 is essentially done for us. You can just assume the cutoff is plus or minus 1.96. In other words, a less than a 5% chance that we would have gotten a sample that much happier or less happy than the general population if the null was true. Now, step 4. We actually have to do the math. So we've established how different the sample needs to be from the population to reject the null. Now we need to find out how different is our sample from the population in reality. So here we have our z-score formula, our sample mean, minus the population mean over the standard error, which is our estimate of sampling error. And here's our little formula for standard error. It's our standard deviation over the square root of the sample size. The population mean was 70. The population standard deviation is 10. If the woman that we gave $10 million scored an 80 on the happiness scale, let's start plugging these things in. So the z-score formula, oh, not math, vampire races, I feel you. I don't like math either. But here we are, we're doing it anyway, and don't worry, I've got it all sorted out for us. So let's start plugging stuff in. The sample mean is 80. Our woman had a happiness score of 80, minus the population mean. So the top of the z-score formula is establishing, in just the original units on the happiness scale, how different is our sample from the population? How different is our treatment group from the control group? The control group, or our population, had a score of 70 on the happiness scale. And then we need to divide by the standard error. So we're going to plug that in. The standard deviation of the population was 10 divided by the sample size. And in this case, the sample size for our sample is only one person. we only gave one person $10 million. There's only one person in our treatment group. Maybe because $10 million, we couldn't afford to have multiple people. So we plug this on the bottom. 80 minus 70 on the top. What is 10 divided by the square root of 1? Anybody know the answer? Maybe I barreled into that a bit, but let's see. 10 divided by the square root of 1. What does that give us? Well, first off, what's the square root of 1? Break it down a bit. What's the square root of 1? Is everybody like, man, I don't want to do math right now? People are fleeing the stream, and I don't blame them. They're like, I didn't sign up for this. I need an adult. So the square root of 1 is 1. 1 squared is 1, so the square root of 1 is also 1. 10 divided by 1? You're 20 plus, that's fair. I'm an adult too, and I also feel like I need an adult when I have to do math. So, 80 minus 70 is 10, divided by 10 divided by 1, which ends up being 10. How about this? What's 10 divided by 10? What does 10 divided by 10 get us? What's our z-score? I don't know how long of a delay there is. Yes, exactly, 1. Good job. Our z-score is 1. The woman who got $10 million, her happiness is 1 standard deviation above the population mean. Oh, you're just kissing numbers. No, you got it right. It's 1. It's 1. It's been a long day. Let's just say it's been a long day. You're fine. I do this all the time. I tell my students to watch out for math mistakes when I actually go out and teach this, because I do make math mistakes while I'm teaching. It's kind of, at least it keeps the students on their toes, right? That's what I always say. At least I'm keeping you on your toes. Anyway, so we've established that the z-score for our sample mean is 1. Our sample mean is 1 standard deviation above the population mean, which means we can move on to step 5. We need to determine if we can reject the null hypothesis. Remember, if our sample z-score is in the tail beyond the cutoff beyond our cutoff, we can reject the null and conclude that our intervention did change people's happiness. If our sample z-score is not in the tail, it's not beyond our cutoff, it's closer to 0 than the cutoff, we have to fail to reject the null, and we can't conclude our intervention changed happiness. In this case, our z-score is positive 1, and our cutoff was plus or minus 1.96. We had to be further from 0 than plus or minus 1.96 to reject the null, but 1 is closer to 0 than that, unfortunately. We did not find a big enough difference to reject the null. It's too likely that this was sampling error. We failed to reject the null hypothesis. Bummer. It happens. It happens to the best of us. It happens constantly. So, step 6, the most important step. What did we find? Well, we didn't find any significant difference here. We did not find a significant difference between the people who got the woman, I guess I should say there was only one person, the woman who got $10 million and the people who did not. Any differences, that difference of 10 points on the happiness scale, we can't conclude that it was anything but sampling error. We can't conclude that it was anything meaningful. So we can't say that giving this woman $10 million led to her being happier 6 months down the line. Bummer. Let's do another. So, in a previous lecture, that's right, we're going to do some more math. In a previous lecture, I was trying to create a video game that helped boost people's mental health. Here are possible results, and we used these results before. I forget exactly which one we went with before, but let's say these are several possible outcomes. As a reminder, this is on the PROMIS scale. The PROMIS scale is a scale that is used in healthcare to measure various things. We're specifically using the PROMIS scale for mental distress, and I'm trying to create a video game that, helps people with stress and trauma and depression and stuff. The population mean for mental distress on the PROMIS scale is 50, and the population standard deviation for mental distress on the PROMIS scale is 10. Our goal is to try and figure out if my video game significantly reduced mental distress. Oh, I literally had them on the slide there. I didn't need to write that at all. You didn't have to see my ugly handwriting yet. Okay. So, let's see. We've got 3 different universes here. Which one do we want to pick today? Oh, I forgot to mention, in the sample, there's 20 people. There's 20 people in the sample. So, let's pick... I think we might have done Universe 2 last time. Let's pick Universe 1. Let's say I have my sample play this video game, and their average mental distress score is 53. So if you're not sure where to start on this, let's look at the formulas and see which one we can do. The z-score formula is the first one here, and it requires the sample mean, which we have, 53, the population mean, which we have, 50, and the population standard error. We don't have the population standard error yet, so we're going to have to figure that out first. So let's go to the standard error formula. The standard error formula here requires the population standard deviation, which we do have, and the population sample size, which we have. So let's start with the standard error formula. The standard error, written as sigma m, is equal to the standard deviation of the population divided by the square root of the sample size. The standard deviation of our population here is 10, divided by the square root of our sample size, which is 20. We've got 20 people we had play this video game. Now, I am not good at math, as we have established. So, I am going to use my calculator to figure out what the square root of 20 is. Okay, 20 square root. Feel free to follow along if you'd like. The square root of 20 is about 4.47. So our standard error is 10 divided by 4.47. Now I can't do that math in my head either. I will guess 4. You were very close. You did a very good job. You were very close. Right? 10 divided by 4.47. Our standard error becomes 2.24. I'm rounding to 2 decimal places. 2.24. And just so we don't lose track of that, I'm also going to write over here, along with some of this other information, our standard error is 2.24. If I don't keep my information together, I start losing track of it. That's why I like to do that. All right, now that we have the standard error, we have everything that we need to calculate our z-score. Find out how far away our sample who's played my video game is from the population. Our sample mean, in this case, we're using the 53 for this one. Sample mean is 53, minus the population mean, which is 50, over the standard error that we just calculated, which was 2.24. There we go. Now we have to figure out how far away our sample mean is from the population mean. 53 minus 50. Our sample is 3 points above the population mean. Already not looking great, because this is mental distress, and I wanted my mental health video game to lower mental distress. My sample has higher mental distress than the population. But is it significantly higher? Is that sampling error? Did I actually do damage to these people with my video game? Did I actually cause psychic damage, or is this just sampling error? I just happened to get a group of 20 people with slightly more mental distress than the population. So to find out, we've got to calculate the z-score. 3 divided by 2.24. And again, I can't do this in my head because I'm bad at math. So 3 divided by 2.24 gives us a z-score of about 1.34. Probably the ads, I recommend them removed. But I need to make money somehow. I'm poor and struggling, and I need money for my labor. All right, so we've calculated our z-score. We're using the standard cutoff of alpha of 0.05. In other words, our z-score needs to be further out than negative 1.96 or positive 1.96 for us to reject the null. So it has to be in the shaded area for us to reject the null and say my video game did affect people's mental health. And if it's closer to 0 than that, then we can't conclude it did anything to people's mental health. So my z-score was 1.34, so that's closer to 0 than 1.96. This is still within the realm of error. This could just be sampling error. We cannot conclude that my video game affected people's mental health, either for better or for worse. Thank goodness, I am not liable for those higher mental distress scores. So this could have just been sampling error. We failed to reject the null hypothesis. We can't conclude my video game did anything to people's mental health, for better or for worse. Yay! Well, I mean, it's sad that it didn't help people feel better, but it's kind of a relief that it didn't make them feel worse, too. So, could be a worse outcome, could be a better outcome, could be a worse outcome. But that is a hypothesis test. Free game with ads? No one? Yeah. That's a hypothesis test. We tested to see if our treatment group, people who played the video game, were different from our control group, people who didn't, and in this case, we failed to reject the null. We couldn't conclude playing the video game changed people's mental distress. Now let's talk about language. I've tried to be very, very careful about how I talk about this stuff, because you can never accept the null. You can never accept the null. I can never say, I failed to reject the null, and therefore these two groups are the same. I can't say I've accepted the null. I can't say I proved the null. That is not a thing I can do. There's always a chance I missed something. There's always a chance of a false negative, that there was a difference that I missed for any number of reasons. Maybe my study was badly designed. Maybe my sample was like a weird sample. Maybe I had a biased sample. Maybe I didn't have enough people. There's a million reasons why you may have failed to reject the null, so we can't accept the null. We can't say conclusively there's no difference. So here's the promise meme. You can't say we accept the null hypothesis, you gotta say we fail to reject the null hypothesis. Me running away from Area 51 with a method to prove if the null is true. These are kind of old memes. When a panelist claims that their non-significant p-value proves the null hypothesis, you fool! You fell victim to one of the classic blunders. I recognize the stroke, twisted mouth, arm paralysis, incoherent speech. P is greater than 0.05. We accept the null hypothesis. Yeah, so, long story, you cannot accept the null. Blunder. I showed it. It's here, we did it. Yep, there it is. If you were waiting for this the whole stream, your time has come. So yeah, you can't accept the null. You also can't prove anything with these types of statistics. If somebody tells you that science has proved that, say, like a glass of wine a day helps depression, or science has proved X or proved Y, specifically if it's a type of science that uses statistics like this, they don't know what they're talking about. They do not understand statistics if they say statistics have proved something. There is always a chance of there's always like at least a 5%, or there's always a 5% chance or so that this was a false positive, that this was a fluke, that we reject the null when there's less than a 5% chance that it was just a coincidence. But that's still a 5% chance. 5% chances happen all the time. 5% is the chance of rolling an SSR, a 4-star unit in Fate Grand Order. This isn't unusual. Because of this, about 1 in 20 hypothesis tests will be a false positive. So you can't definitively prove that you found something. And I talked about this a bit in my video on that BL brain scan paper. Yeah, we can't prove anything. We can't prove stuff. So don't say prove. This is my pet peeve. If you're talking about statistics, don't say prove. And if somebody says prove when they're talking about statistics, they don't know what they're talking about. You shouldn't trust them. That might be an overgeneralization, but you get the point. I have a meme for this too. When I hear someone use the null hypothesis significant testing to say they proved something, what's wrong with people? Yeah, it doesn't prove anything. There's always a gray goose in the white. Exactly. All it would take is that one gray goose, and yeah, pretty much. All it takes is one counterexample. And also in this, so all it takes is one counterexample for us to show that the null isn't true, which is why we can't accept the null, because all it would take is one rare counterexample, like the one gray goose. And if we say all geese are white, it only takes one gray goose to show that we're wrong. In this case, this is kind of you have to do the same thing multiple times, and there's always a chance that you just get a bunch of false positives in a row. People have been struck by lightning twice. There's always a chance that we've been wrong a lot of times in a row, but the more times in a row we find the same thing, the less and less and less likely it gets that it's just a false positive. Yeah, science really is just the pursuit of being as sure as you possibly can be about something. Hypothesis testing, does this sound like Bayes' theory? No, Bayes! Please don't talk about... No, you can talk about Bayes. I'm just scared of Bayesian statistics. I'm sorry. I need to learn Bayesian statistics someday, but that day is not today. We're doing frequentist here, because most of psychology is frequentist statistics, so that's my excuse. I think Bayes has ways of testing the null hypothesis and actually supporting the null hypothesis, whereas frequentist statistics does not. Anyway, that's the end of my lecture for now. But I'm happy to take any questions or comments or anything like that at this point. Happy to talk about it, especially because I'm going to be going on a break from these lectures after this to deal with my job at my other university, which is... I got an extra class suddenly, so I don't have much time for this. Antipathies towards Bayes' theorem unrelated to its teaching. I have a problem with Bayes' theorem too, but it's kind of petty. I think that Bayesians tend to think that they're better than frequentists, when really they're also making assumptions. We assume that there's a normal distribution, they just try and guess the geese example is something a guy taught me on YouTube about quantics. An example, they later found out there are 3 lakes where white geese were even more rare despite having a lake in their name. Ooh, I'll have to check that out. I don't know that much about quantics. I'm not sure what that is, really. It sounds interesting. I really like that kind of philosophy. It's very interesting, and it's part of why the method of thinking is very, very similar. It's why I tell my students statistics isn't so much a math thing as it is a way of thinking. It's it's kind of its own weird little form of philosophy with more numbers. It's a very, very odd way of thinking too. I think some of my students are scared of the math portion of it. Other of my students are scared of the reasoning portion of it, and honestly, I consider both pretty darn difficult. Well, the math part isn't difficult, but I'm just bad at math, so maybe that's me, but... White Goose Lake is the one all white geese are native from, so locally the first statistic was right, globally it wasn't. Ah, that makes sense. Statistical mechanics is an interesting lens. I'll have to check out more of that. Honestly, I'm decent at teaching, introductory statistics, but the more advanced stuff I don't understand all that much. I would love to look more into it. I've taken classes on, more complicated stuff, multi-level modeling and structural equation modeling and machine learning and agent-based modeling, but ooh, it's from Spain. If it's in English, I can understand it. I've forgotten all the Spanish I ever learned. Boltzmann distribution of how many particles are of a certain energy level. Oh my gosh, I've never heard of a Boltzmann distribution. I wonder what shape it is. Is that a specific shape of distribution, or is it called that because it's a distribution of certain types of things? Oh, I've got a lot to look up. I have a lot to learn today. I'm very excited about it. Oh, it isn't in English? Darn, darn. I need to relearn Spanish, but I've come to the conclusion, I've been learning Japanese, and I've come to the conclusion that I can only hold two languages in my head at a given time. For every Japanese word I learn, a Spanish word leaves my brain. It's really depressing. I took like 7 years of Spanish class, and I cannot say a sentence in it anymore. Ooh, an inverse exponent. Oh, I see, I see, I see. I'll have to check that out. Got a lot to learn. Thank you. Thank you. Language. Language is so fun. Oh, there's so many, and there's so much interesting stuff with the psychology of language. Like there's the Sapir-Whorf hypothesis, and like, was learning Japanese, was learning the Japanese days of the week. I could not help but think, miracles. Oh no. I like the Japanese days of the week because they're like, I think it's fun that they're all associated with elements. I know to an extent, like in English, they're also associated with like gods and things like that, but foreign language mode crosses all the wires. It's like if I try and form a sentence in Spanish, Japanese comes out of my mouth at this point. It's really bad. The whole color and language thing is a big one. Yeah, the color and language thing, that's part of the whole Sapir-Whorf hypothesis. Oh yeah. Oh, that's great. That's how I feel about Japanese months. It's just first month, second month, third month, fourth month, and it's like, that's awesome. Perfect. Yeah, the Sapir-Whorf hypothesis, I have heard that that's had trouble replicating lately, but that's like the color one, like how our perception of the world is influenced by the language that we have to communicate about it. And I think there's a lot of problems of like the confounding between, can you actually measure that? Because if they're communicating in a language, they may be able to perceive certain things, but don't necessarily have the language to communicate what they're perceiving. English is weird. I feel like English is a pain in the butt, but sometimes I feel like I give it more credit of being a pain than it actually is. Because like at least, I used to complain about how Japanese has effectively 3 alphabets, and then somebody pointed out that English has 2. We have lowercase and capital. So you know what? Fair. I feel like that's the equivalent of, hiragana versus katakana. Midori ga suki desu. Hai. Murasaki ga suki desu. Kuro ga suki desu. Demo, kuro wa iro janai. Yeah, kanji is, oh my gosh. Yeah, kanji is so much. I'm trying to learn kanji right now, and it is horrible. Oh, no, that's a pretty good one. Midori ga suki desu. That's pretty good. I think that's pretty good. You formed an entire grammatically correct sentence, at least with my understanding of Japanese grammar, which admittedly is not great. It does basically use a lot of the same. Yeah, my sister took Chinese in school, and so she actually recognizes a lot of kanji. She was super back into anime and stuff back in the day, not so much anymore. Like she knows more kanji than I do, so she can actually, to some extent, read more Japanese than I can. Yeah, there's a lot of similar. They use a lot of the same characters for a lot of the same meanings, is my understanding. But the pronunciations are completely different, and sometimes the same character means different things. And I think, yeah, like I don't know too much about the topic, but you won't know how it's pronounced. Yeah, I've heard that like different dialects or different like types of Chinese can they can both read the same passage, but like speaking wise, they're not mutually intelligible because the characters are read the same, or like the characters have the same meaning in the same order, but I probably shouldn't be talking about this because I actually don't know how much of what I'm saying is true. This is something that I have heard. I would have to do more research to like confirm this. Maybe I should shut up. I don't want to say things that are false. I'm trying to couch it a lot. Linguistic hearsay. There's so much hearsay in this. Oh, yay! Yay! Oh my gosh. I've started reading some like novels translated from Chinese in the past few years, and the pronunciation system has me screwed up. I'm so grateful. The funny thing about learning Japanese after learning Spanish was that they pronounced the vowels more or less the same, which was really nice. You gotta love it that these two very different languages have the same pronunciation for vowels. Oh, delightful. My brain is like getting away from me, but I think it's really interesting how like oh, we speak of it because it's fascinating, not because right. It's totally possible to think about the idea of research ecosystems that like they're their own cultural islands as a result. Yeah. Oh man, I brought this up or like somebody brought this up in my comments section once of like concerns about I was talking about a character in an anime, and they were concerned because I was using only English language research on hyperthymesia, like really photographic memory, hyperthymesia. I was only citing English sources for it, and they're like, well, this character is from a Japanese game, so wouldn't they only have Japanese sources? And like to some extent, I have mixed feelings about it, but like the international language of psychology is English. Like psychological conferences, even psychological conferences in Japan, the major international ones are conducted in English. And I don't, that's not great, but at least to some extent it does help overcome that language barrier because all the major journals that I'm aware of in psychology are published in English. And that is somewhat biased, like for me, in that, you know, like I speak English, so of course those are the ones I'm reading. And I do know there's psychology journals in other languages as well, but the vast majority is published in English, which is helpful. I think the whole research ecosystem too, though, it's not just language, it gets into discipline. Like sociology, psychology, political science, communications, anthropology, all of these disciplines, a lot of us are studying the same things, but we don't talk to each other. And like, even if you're trying to do a literature search, we use different terminology to discuss the same phenomena. And that means that we're missing out on like, we're all talking past each other. It really sucks. I wish there was more cross-discipline communication. And sometimes even within the discipline. I once took this class on like thinking about the future thinking, which is a phenomenon in psychology. And we read a book that was a collection of chapters written by a bunch of different researchers who study this. And I'd say probably 60 to 70% of the book chapters were all about exactly the same topic, but the researchers were all using different terminology. But like the way they were defining things, they were all clearly talking about the same concepts, but because they had named it different things, it was they were all just like doing exactly the same thing and and like nobody realized it because they were using different words for the same thing. And I think halfway through that seminar, like halfway through the semester, the person teaching the class just like stared at the book like, wow. A similar thing happens in spinodal decomposition for material sciences and Turing patterns from biology and chemistry. Probably so. It's real. I really wish there was some more standardized like language for things. I've thought about, at least in like my narrow areas, actually creating a spreadsheet where like I just straight up create like, this is the term that they use in this area and this area and this area. VR chat classrooms are cool in that way. The sense of community doesn't limit nationality only to own a device that doesn't and don't have a rotten toxic personality. That sounds really cool. I'd love to try. VR chat sounds like there's a lot of interesting things going on there. It reminds me of when I was an undergrad. One of my professors talked about how she was in like a human computer interaction discipline, and they would hold conferences in Second Life. It reminds me of that kind of. I think there are people who hold meetings and stuff in like VR chat or like conferences in VR chat, and I just think that's awesome. I think that is so cool. And it's nice because there's a lot of concerns about, say, graduate students not being able to afford to travel to international conferences. And I think that is really cool. I've also heard of academics, specifically like in that human-computer interaction space and like computer stuff, computer science, holding conferences and like lab meetings in World of Warcraft. Oh, I love it. I love it. I wish that that was a thing that that my labs did more often, that the kind of labs that I'm in did more often, but no. That would be great though. There was a short period there where my lab had a Minecraft server, but it was only me and one other grad student in it, so that kind of died, unfortunately. uh, yeah. I mean, at the core of it, academics are gonna academic. They're gonna be nerdy, and that nerdery extends to many different areas, even outside of academia. Oh, I feel like that's why, like, as Phi goes along on the eternal quest, so many academic VTubers are popping up. We're all isolated to an extent, but there's more, like, we keep finding more and more of us, and it's like, you know what? Of course, this is what we call a comorbidity. Yes, yes, this is absolutely what we call a comorbidity. There aren't as many weeaboos in science. You know, that's true. There aren't that many weeaboos in science. There's a lot of gamers in science. But I'd say the weeaboo population is roughly equivalent to the general population these days. But like in terms of like people that I know who built their own PC specifically for gaming, there's quite a few of those in academia that I've met. Your second week in someone saying they watched anime. Avatar. Oh no. Oh man, there's this grad student in my department, and I rarely ever see him or encounter him. But but he found out that I like anime, which is honestly not that hard to find out. I'm very high key about it. It is like my life outside of academia, and he thinks I'm the coolest person in the department because of it. He always wants to talk to me about it, but unfortunately, like, our tastes in anime and our opinions on things are very different, which sucks, but when you find someone, you gotta hold on to them. An episode in Assassination Classroom where the episode was about solving a material science equation. Oh, I love that. So I love when there's that whole anime Science Fell in Love that's about a human computer interaction, sort of like information science grad students, and I love that shit. It's so fun. I was never a nerdy, but I always thought people can't really be interested in math symbols. They probably enjoy solving math because the reactions they give and share other people understand. Yeah, I don't like math. I don't like math, but I like statistics, not because of the process of statistics, though. Actually, I have started to like coding, but like, I like it because finding things, you know? It's really cool. I always get really excited to see how the analysis is going to come out. I get more excited about the results of the analysis than actually doing the analysis. Oh, it actually went to death of the problems. Math is a good tool for forming intuitions in my... Yeah, I have trouble thinking in a mathematical way, but like, I get that to some extent, yeah. I think it works for some people better than it does for others, and maybe that's just exposure to math or something. Like, I don't want to say this is like a fixed mindset thing. Yeah, it can quickly bog things down. I have a good friend who's an economist, and economists try and express a lot of their like theories and stuff like that in the form of equations, and sometimes he'll have me read over his manuscripts for him before he submits them to peer review, because he's like, I want to make sure that this is intelligible to somebody else, and I don't think it's that he's necessarily a bad writer. I think it's just that I cannot... I have feelings about economists, but he is an economist that I'm willing to accept. I'm willing to accept him as an economist because I trust him, but most other economists I do not trust. But trying to read an economic paper where they try and put human things into equations, just I cannot process information that way. Oh my gosh. I had a way easier time reading the biology paper that you sent me and like looking at the other biology papers than I have ever had reading a single economics paper, which is wild to me because economics and psychology should be a lot closer together than psychology and biology, or at least my area of psychology and biology. And yet so, I didn't say anything about what the paper was about or anything like that, but yeah, kind of spoilers. I have recently read a biology paper, and Phi was the one who sent it to me. I realize I read it way too early and I'm gonna have to reread it again at least once or twice more. This is what happens when you do things ahead of time. But I took very thorough notes. I color-coded my notes on it. I did. I always color-code my notes or else I get lost in them. Oh no, I just realized I'm drinking a caffeinated beverage and I'm not gonna be able to sleep tonight. That's fine. My first class is afternoon tomorrow, so it'll be okay. People who read the papers you send them read them more in depth than I ever did. Well, I feel like at least like, you know, well I'm not gonna do this on your paper. I'm that horrible person in journal club who will like, this statistic doesn't make sense. They did this wrong. They're interpreting this wrong and stuff. I read papers way too closely and I become kind of almost toxic about it, and I hate that about myself. I'm really trying to work on it, but like with your paper, I had to read it in depth because, you know, it's not a discipline that if it was a psychology paper, I probably wouldn't have read it quite as in depth because I'm used to how psychologists write and stuff like that. Yeah. It's something you've got to work your way out of. Your advisor said, I didn't have an advisor to set these straight. Well, I did have advisors, but they were kind of like, they almost reinforced it. Like, my first advisor was really into the open science movement, and even before that, like, I went to journal clubs in a lab that was big in open science, and some of the more, like, intense members of open science, I would say. And so, yeah. And then you critically think uncritically, it's kind of, yeah. Oh, yeah. Yeah, I think it's good to read critically, but you don't want to be toxic in reading critically, and I'm still working on that. I have been a peer reviewer for various things, and I like to think that I'm able to be constructive as a peer review. If I'm reading, like, undergraduate papers, I'm much chiller, because, like, they're learning, you know? Like, I'm like, you are learning, and I need to remind myself that not everybody submitting to a journal like, is at the tail end of their career. What can you take away from this? I like that a lot. But that's so true. Even bad papers have something in them. That's so true. You can always learn something from any paper you read. And if it's been published, there is absolutely something there. There is something there. And I feel like I get way too in the weeds a lot of the time and forget to look at the bigger picture with papers. And I really need to get over that habit because that's not the point. That's not the point is not the little details. The point is the overall message and overall what they found. Yeah. But shut my brain off in a group. Yeah. Yeah. I think that's I mean, you want to read critically for peer review, but you also don't want to be a jerk. Yeah, I think that's a good way, like, of thinking about it. What did I take away from this paper? I think I need to think about that more, because, yeah, my last grad school advisor was more along that line, but, like, I was introduced to reading journal articles and, like, journal clubs and lab meetings and things like that by some people who kind of made it their mission to pick apart papers and be very critical, and I don't think that's a great or healthy attitude to have, and I think it's something that I'm going to need to work on as a human being, because I don't want to be that person. Yeah. And, you know, the people that you're trained by can make a big difference in how you view the world, and you've got to make an effort to break out of that, I think. Yeah, I don't know. I feel like I'm getting a little philosophical here. I mean, my work certainly isn't perfect. Your advisor, oh, that's so good. Your advisor can really make or break your grad school experience. Like I said, I had two advisors, and one of them was not so great. Like they both have good side, like pros and cons to them. But one of them was incredible. My one for my later years was absolutely incredible. She's freaking amazing human being and researcher and teacher and mentor, and I want to be like that. I would love to be like that someday. Absolutely. If I could take all the best qualities of my advisors and be like that, that would be incredible. I'm not sure if that's something a human being could do, but oh, would like to do. Do you know of maladaptive daydreaming? I don't actually know that much about that. I don't. That feels like it might be tangentially actually kind of related to some of the research I do in a way. But I don't actually know that much about it. I know that so is that like spending too much time daydreaming or like too much counterfactual thinking? Like, oh, if only I had done this, then this would have been better kind of deal? I'll have to look into that. Because counterfactual thinking can be pretty maladaptive. Um, I guess it depends on the type of counterfactual thinking you're thinking about. Like if it's like, oh, I just barely missed that, that would be probably maladaptive counterfactual thinking. But if you're thinking, oh, well, I almost missed that, but then I didn't, that could have been much worse than it was, is probably more adaptive, or at least like, more mentally healthy, more conducive to a positive mental state kind of deal. Yeah, I'm not super familiar with it. It's not an actual issue yet. Yeah, I mean, like as far as like pathologies are concerned, like pathologies of stuff like that, there's a lot of maladaptive thought processes that most people have. Like most people have a lot of maladaptive thought processes. It's just the question of, do they cross the threshold into actually being like a pathological? Like I have a lot of maladaptive thought processes, and some of them are definitely pathological. Psychology, people go into psychology for a reason. But, just human beings have a lot of maladaptive thought processes that aren't necessarily, they don't rise to that level necessarily. This might be one of them. Oh, I'd love to hear more about it. Yeah. And I'll probably do some reading about it after the stream. Absolutely. Absolutely. It sounds really, really interesting. I'm really interested in like on a casual level, not necessarily as a research thing. I haven't done any research on it, but like dreams and like not necessarily, like psychoanalyzing dreams, but things that happen around sleep, like myoclonic jerks, I think is the name of that thing, where like suddenly it feels like you're falling just as you're falling asleep, or sleep paralysis, or hypnagogic hallucinations. All that stuff is super interesting to me, and I've never really looked into it too much, but it's so cool the things that our brain does. It's like no wonder people used to believe that nightmares were creatures that would sit on your chest and stuff if hypnagogic hallucinations and sleep paralysis are a thing. Like, of course. So even if biased, I can try and be as objective as you need, probably. Oh, yeah. I mean, I can't talk about individual thing, like an individual. I'm happy to talk about psychological concepts, but as far as like individuals, like mental experiences are concerned and maladaptive thought patterns, I'm not in the least qualified for that. I'm not that kind of psychologist, so I can't like help with personal individual experiences, and I'm not qualified to treat anyone, but yeah, like if you have like a general definition for maladaptive daydreaming or something like that, I'd love to hear about it, and I'll probably read up on it after this. I'm excited about that. That might be my evening reading. But yeah, I am not a clinician. I intentionally avoided becoming a clinician because I didn't think that that would be a healthy career path for me. I tend to over empathize with people, and I figured I'd have a breakdown if I had to deal with other people's distress at that level. And for the sake of education, I would love to hear for the sake of education. Yeah, thank you. I'm sorry I can't help, but I might know some resources that I could point you towards if you ever need them. Like if you reach out via some sort of message or something. Not being a clinician, it hasn't stopped my family from asking me medical questions. I'm so sorry. I get it though. I get it. I've had I don't think I've had I have had people ask, like, if you're a psych major, the running joke is that people will be like, diagnose me, and it's like I'm not qualified to diagnose anyone. Does YouTube have, I think YouTube might have messaging. Uh, I'll have to check in on that. I think my email is also available on my channel about, maybe? Anyway, yeah, I'm not qualified. I have students who try and diagnose me. It's so funny. I'm like, buddy, you've taken Psych 100. you are you are not qualified to do that. My sister actually will ask me questions about my area of interest, like my specific area of expertise. She will ask me for about that. And like that's great and all, because that's my area of expertise and I can actually speak with authority on that. Except then she'll start arguing with me. She'll say, I think you're wrong and I'm right. And I'm like, buddy, sis, you asked me because this is my area of expertise. Why did you ask me if you think you already know the answer? Come on. Come on. I guess my parents do tend to think that psychology is very much only mental health. Oh, that's annoying. You shouldn't need that. Hmm. Weird. Weird. Yeah, definitely don't sign up for anything. Don't pay money for something that you wouldn't otherwise. That's okay. I'll just look it up. Thank you though. I'll look it up after this. I can read up on it. Maybe I can find some articles. Yeah. Like a review article. I love review articles. Bless the people who go out of their way to do review articles. They are the heroes that we need. Yeah, yeah. Can you share your email? I think I'm just gonna look it up on my own. I don't want to put you to any trouble. I don't want to put you to any trouble. I'll just look it up on my own. The thalamus of the research ecosystem. Yes. Oh my gosh, what would we do without them? What would we do without them? It feels like kind of a thankless job, like, but then I guess you must get a lot of citations. I've had friends do that, but oh my gosh, the literature searches you'd have to do would be wild. The amount of reading you'd need to do. I don't even want to think about it. Then again, I probably could write a decent one for my area of expertise. I have like an entire spreadsheet of every article I've ever read about it, which I think is almost every article published before 2019. After 2019, I kind of slacked off, and now I'm way behind, but I guess if you're in a specific area long enough, it might not actually be that hard to write a proper review article. Oh. Hmm. Yeah, I'm gonna... Oh, yeah, yeah. I try and do meta-analysis. Meta-analyses. Oh my gosh, I've done a mini meta before, like a meta-analysis on stuff, but like a full-on meta-analysis sounds like a night. I tried to do one once, but there simply wasn't enough studies on it. Yeah. I tend to avoid talking about personal experiences or like asking about personal experiences because like that gets out of my area of expertise, and then also that gets like I'm not qualified to talk about that stuff. And also that's like a sample size of one, so everybody has their unique individual experiences, right? And everybody has very specific experiences. There's a lot of things that influence how we view the world and our experiences, and that includes our past and the type of people we're around, the culture that we're in, our own cognition and stuff. And so if there's a phenomenon, I generally want to hear about what it's like on average across a whole bunch of people rather than reading individual testimonials. And that doesn't mean that your experience isn't important. Your experience is very important and interesting. I feel like I know that you volunteered, but it feels invasive for me to ask for that or to read that. And it's kind of like an educator thing, you know, like you've got to keep at least some level of distance as an educator between you and your students, if that makes it's and I'm sorry, I know this might sound weird, but it's like a personal sort of philosophy of mine that makes sense. I don't know if that makes sense. But sorry. I'm kind of rambling at this point. Boundary. Yeah, boundary might be a good word for it. It's a boundary to protect me, and also I would say to make sure to protect other things. Yeah, okay, all right. Yeah, and if you do need I know about resources in the US. I don't know resources in other countries, but I am aware of some resources in the US if like that would be useful. But they're pretty generalized things because, you know, that's an entire large country. So I don't know more specific things. And of course that's only one country in the world, but yeah. I worry that that kind of thing. And also, you know, like I'm sure this wouldn't be a problem with y'all, but like, you know, you got to be careful about parasocial relationships and stuff like that. I've had students develop parasocial relationships with me before, and that's not necessarily a great situation to be in. Not that I think any of y'all would do that, you know, but you got to be careful. You got to be careful. Yeah. So it's the thing. It's the thing that you do with syllabi. Like, I will apply this policy to everybody equally for the sake of fairness and equity and stuff. Even if I don't think it would be a problem with a specific individual, I'm going to apply it to everyone, kind of deal. Yeah, for the sake of consistency, and also because I'm an airhead, and if I don't do things consistently, then I will lose my own head first. Ooh, yeah. Yeah, I would love to do a study on parasocial relationships, actually. That's one of the topics I'd love to. I don't know much about it, but I've actually peer reviewed a paper about parasocial relationships before, but I was like looking at a different aspect of it. Yeah. Parasocial relationships are fascinating. I know a researcher who's studying that right now, and they said to get in touch if I ever wanted to look at it. I'll have to, maybe I can do a stream. Oh yeah, absolutely. Go for it. I would love to hear about it. You met Psy through a stream where I was chatting with GigaChat about parasocial relationships. Oh, nice. That's so cool. Man, I really want to talk to Psy one day. Psy sounds really like an Oh, but I must be careful not to form a parasocial relationship with Psy. The street might go both ways. I gotta be very, very careful. Armchair. Oh, I think I've heard of them. I'll have to check that out. I'll definitely look into that. Thank you. Yeah, I don't mind at all people mentioning other channels in the chat. I don't like self-promotion can get kind of annoying, but like if you're saying, hey, this sounds like another good resource, I'd love to hear about it. I think later on when I get like if I end up getting a bigger viewer base, I might have to crack down on that, if only because I'd like to like vet the channels that are mentioned in chat to make sure nobody's sharing any like, you know, pseudoscience stuff or whatever. For now though, well, things are still small. Maybe it's okay. Maybe I should put a disclaimer. Armchair Expert, I will check out Armchair Expert, but I have not vetted them to see things or something. You know, just in case. Oh, this has been really fun. I'm kind of sad that I need to go on a break from these for a while now. I've really enjoyed talking to everyone here. Oh, man. But I just know I'm going to get drained as the semester goes on, and I need to save my voice, and my voice is already going. Oh, not Armchair Expert, that guy I don't even know. Oh, okay. There was that Frontiers article, which had like... Frontiers! Good old Frontiers. I guess Frontiers has a bit of a reputation. I imagine it varies a lot across... No, I know exactly which one you're referring to. It's the mice, isn't it? The certain part of their body that was AI generated. And oh my gosh. Oh, the Armchair Expert with a 1. Okay. Gotcha. Yeah, that was a big thing for a while there. That it's so sad to me. Yeah, I don't think Frontiers is necessarily bad. I think it, at least in Frontiers in psychology, has a bit of a reputation as being like having lower standards. Which, yeah, like Marlon says, it can be very hit or miss in that respect. Like, some people will submit there because they want to some people submit there because they just want to get published fast. Like I sent my dissertation to a journal that has relatively looser standards, not because I didn't think it could go into a high tier journal. In fact, it did get a revise and resubmit for a high tier journal. But because I want to focus on teaching, I didn't want to, like, you know, do a whole bunch of revisions and stuff. I wanted a relatively easy path through. Um, yeah, I've heard some weird things about the reviewing system with well, getting peer reviewers anywhere is hard these days. Like, I hear after the pandemics, getting people to peer review papers has been like a bit of a nightmare, which is unfortunate. But like, I get it. I mean, it's unpaid labor. Yeah. Hmm. Man. Speaking of journals, didn't the whole board of one of the Elsevier journals step down recently to like protest fees? Oh, so imagine paying for peer review. Imagine paying for labor. Says every journal out there. I guess they pay like their major editors and stuff, but oh my gosh, the profit margins on some of these things must be wild. Like, if you want to publish open access, that's one of the wildest things. Like, have you seen these fees? I published open access, and like they charge differently based on your discipline, but like to publish something open access in psychology can be like 1,500 to like $3,000 for them to publish your paper. It's insane. And of course that's after it passes peer review. Oh, sure. Go for it. Mm-hmm. Yeah, send me the link on Twitter. I will look at it. Yeah, they pay their executives and their board members and their, oh my gosh. The whole academic publishing industry really needs an overhaul. But it's, you know, for like tenure track faculty, I feel like that feels risky to overhaul it, and it has a lot of momentum as it is. But we are slowly getting there. I mean, there's more open access journals. We're seeing more things like registered reports and stuff like that, and like badges for open access data and that kind of thing, which is great. And like short reports are a thing, which I think is awesome. But, you know, the system's kind of crumbling, I would say. Oh, thank you. I will take a look at it. Absolutely take a look at it. Mm-hmm. Oh, I think my voice is kind of going out on PLOS, my beloved. Yes, I've published in PLOS before. My one beef with PLOS is that the state of publishing in PLOS is like, oh my gosh. Like, they have so many rules for publishing in PLOS that are not accessible on their website. They have a form you have to fill out for like to demonstrate that you have IRB approval. And they're like, why didn't you send us this form? And I'm like, it's not listed anywhere on any of your checklists, and it's not accessible on your website. And they tried to send it to me like 3 different times, and each time the file was corrupted. And it took 4 times for them to get me this form that I never knew I had to fill out. Like, the process of publishing with PLOS can be exhausting, but I deeply, deeply appreciate that it is open source the way that it is. But that also means, yeah, they charged me nearly $2,000 to publish with them because they're open source. Oh, yay. Yay. That was expensive. I don't have funding. I had to pay out of my own pocket. When our Cell that's big and famous, the journal Cells, which is we have the big famous journal Cell it. Oh no. This isn't entirely related, but it reminded me of this. I'm a social psychologist, and social psychology and personality psychology tend to get lumped together, and like almost all of our journals are some variation of the letters S and P. We have like PSPB, which is the Personality and Social Psychology Bulletin. We have JPSP, the Journal of Personality and Social Psychology. It's just like different like orders of the letter, different combinations of the letters S and P, and then maybe one other letter like a J or a B somewhere in there into eternity. Oh my gosh, it's a whole thing. Journal names are a whole thing. Some of them are like, oh, that's clearly a journal, and others are like, what is this? I have no idea what that is. I remember first coming into grad school, and one of the scariest things was people just rattling off journal acronyms, and I had no idea what they were talking about. Like, oh, I have an AMSP, or oh yeah, we just got a JPSP, or we're getting into PSPB, and I'm like, what is this? What are you saying? Is this a different language? Who are you? Where am I? Oh my gosh, I lost track of that, and I kept getting them all confused because, like in social psychology, all of them have a bunch of S's and P's in them. It's hard to tell whether highly topical specialized journals are legit or not. Yeah. Oh man, it is. I think the easiest way to tell, unfortunately, it's not a very efficient way to tell, but of course the easiest way to tell is when like the Journal of Medical Science emails you because they want you to submit a paper for their special issue on like liver cancer or whatever, and you're like, I'm a psychologist. I don't know anything about liver cancer. I don't even know where the liver is. That's how you can tell, but that's not a very useful way to tell. I get so many of those emails, though. For some reason, it's specifically medical journals that just keep targeting me, like, publish your research about blah, and I'm like, you are barking so far up the wrong tree that you are barking up a cactus or something. You aren't even barking up a tree, buddy. Oh my gosh. Wild stuff. Wild stuff. But yeah, once they get that specific, it starts getting a little suspicious. If they got a very specific name, just kind of give them a little bit of a side eye. Food science PhD specialized in cheese being asked to review a neuroscience journal or something. I have had one or two occasions where, like, somebody has asked me to review something wildly out of my area of expertise, and I had to be like, I'm sorry, I can't. And on at least one occasion, they came back with, like, please, everybody else has turned us down. You're our only hope. And I'm like, does that even count as peer review anymore? I don't think that counts as peer review anymore, buddy. I'm gonna have to say no, because I don't know anything about this topic. Oh my gosh. It's sad that, I mean, I guess the only real incentive for doing peer reviews is that the editor likes you a bit more, maybe. I don't know. My advisor always framed it as like a pay it forward thing. Like, for every paper you submit to a journal, you should do 2 peer reviews, because 2 or 3 people are peer reviewing your paper. So you should, like, sort of pay it back. Is it good for making... I don't know if it's good for making connections, but I think if there's anything, it would be potentially good for that. But, like, of course, it's like, it's blind peer review, right? So the only person who's going to know your name, unless you sign your review, is going to be the editor who's in charge of the paper. So if anything, I guess you make a connection with them. But as I understand it, like, saying yes to peer review too many times means you become the go-to person for that editor, and then they just ask you to peer review, like, every paper they're having trouble getting reviews on, and at that point, maybe the name recognition isn't great. And yeah, it does get you reading the literature. On the other hand, it might mean sometimes you're reading papers that will never get published. I did have... One of the peer reviews I did was for a paper that I think was very, very interesting, but who's the poor soul that needs to bite the bullet as a first reviewer? So I actually heard recently that, so the reviews get turned in, and the editor only sends things in to the people who wrote the original paper after they've received all the reviews, or at least all the reviews they think they're going to get. And then the editor's the one who puts the reviews in order. And I've heard that they, like, specifically order the reviews. I think it's like, you get maybe it's a negative, then a positive, and then a negative. No, it's a positive, negative, positive, or something. They try and put, like, start with a positive review. So reviewer number 1 is seen as usually a pretty positive one. And then there's this kind of meme in research communities that reviewer 2, so the second review that they put for you to read, is the one where that person gets really mean and unnecessarily awful. We have this, like, reviewer 2 means in like academic circles means somebody who's like incredibly salty, overly critical kind of deal. uh so being the first reviewer might actually be a good thing. Because that's the one that the person who wrote the paper is probably going to perceive the most positively, because the reviewer that gets put first is usually the most positive one, I think. So maybe they're not the poor soul. Maybe the poor soul's reviewer too, but usually reviewer two has earned their spot. Like, it's kind of sad, but, you know, like, a lot of academics, maybe not a lot, but like there's this sort of pressure to be the smartest person in the room when you're an academic. And sometimes people feel the need to show that they're the smartest person in the room by ripping other people's work apart, which is really unfortunate. And I don't think that's a really good way of showing it, but I think that might explain why reviewer 2 is a thing that exists. They're being like, look how smart I am. Look, I found all these holes in your work kind of deal. And it's just a very toxic mindset. And like, I get it. I get why it happens, but I mean, the competitive nature of academia probably doesn't help. But I mean, that varies wildly from department to department too. I think my department isn't a very competitive one, but I know others, they'll pit their grad students against each other, which is a horrible thing to do. Grad school's stressful enough. I don't want any of my students to be reviewer 2. Good. Yes, we must raise the next generation of academics to be kind people. Ooh, is there like research into the psychology of the research ecosystem? Yeah. Yes, there is. I've actually... Oh, I shouldn't say that. Maybe I should. Maybe I can say that. It's general enough. Meta-science is a whole area. So I've done some meta-science. I have done research about research and research about researchers in the past. I do not recommend it because, like, if you give researchers a survey, they will start critiquing the survey as they're filling it out. Like, the comments at the end of the survey will be like, why did you use a 5-point Likert scale? You should have used a 7-point Likert scale. Here's a citation for a paper that shows it has better psychometric value. Why did you use this measure of this particular demographic when this one is so much better? I would have done this survey differently. Like... Yeah, it is kind of intoxicating to find flaws in works, which is a problem, because it can lead to some pretty toxic, but it, like, when you're doing it, it feels like sport or game. Yeah, it is another data point. I got to do some qualitative coding one time of, like, a bunch of, like, open-ended responses from researchers, so I just read a whole bunch of paragraphs on a particular topic that a bunch of researchers had written, and it was a whole thing. Like, a lot of them were really insightful and funny, and some of them got real snarky about it. We actually created, I think, a category. I don't remember what we named it, but there was a whole category in our coding that was, like, snark or sarcasm or something like that for researchers who were just being real snarky. It was a fun... I love qualitative coding, but doing research on other researchers is not a thing that I would recommend for the faint of heart, because your participants try and be peer reviewers, and that is not a fun time for anyone. Maybe it's fun for them, I don't know. Maybe it's like enrichment in the enclosure. But as the person who, like, designed the survey, it can really suck. Oh man, I think I should probably end the stream soon if I want to have any voice for the lectures that I need to do tomorrow. It would be really bad if I went into class and I just, like, tried to start lecturing and my voice gave out. I can feel it getting scratchy. I don't know if you can hear it, but it's getting a little scratchy. So I think I'm gonna have to end the stream, but yeah. Thank you all so much for coming. I had a lot of fun talking with all of you, and I'll see you at some indeterminate date in the future. Take care, y'all. Yeah, I will absolutely hydrate myself immediately after this. I'm gonna go chug a glass of water. Take care, y'all. Bye.